All right, ladies and gentlemen, we are on page 7, I believe, of our notes right now. And we are looking at how to solve quadratic equations by completing the square. And if you notice, we spent a lot of time on how to complete the square. We've spent 2 class periods on completing the square. However, the question is, what is even the point of doing this? Well, if you remember in our second day of notes, we learned our second way of solving a quadratic equation algebraically. And that way is to, plain and simply, if I have something like this, x minus 3 quantity squared equals 25, all I have to do is square root both sides, and I end up getting x minus 3 equals plus or minus 5, which means x equals 3 plus or minus 5. So that gives me my two answers of 3 plus 5 equals 8, and 3 minus 5 equals -2. So that's what I would have to do in order to solve this problem, correct? And then we also learned how to solve a quadratic equation by factoring. So for example, if you had something like this, x squared plus 8x plus 12 equals 0, and I asked you to solve this by factoring, you would factor it, and you would end up getting x here and x here, and then you would get 6 here and 2 here. Add 6, add 2. My carets end up giving me the 8x that I want, so that will work for me, and then I just set each part equal to 0, so x plus 6 equals 0, and x plus 2 equals 0, which means that my answers are going to be -6 and -2. Okay? Now, the cool thing about this is that I can actually take this problem right here and solve it by completing the square and then making it a perfect square root and solving it from there. So let's try this another way. Again, the problem is x squared plus 8x plus 12, right? So I'm going to equal 0. I'm going to leave a little bit of space, x squared plus 8x, leave some space, and then I'm going to say equals 0 over here. So to complete the square, I take the b value, cut it in half, and then square it. So 8 divided by 2 is 4. 4 squared gives me 16. So I'm going to add 16 over here, but I'm going to subtract 16 on the same side in order to balance it out. Now I have my perfect square trinomial, which factors out to x plus 4 quantity squared, and then I combine my like terms, -4 equals 0. Nothing from this is new. However, now that I've done this, it's so easy for me to solve this problem. I just have to add 4 to both sides, and then I get x plus 4 quantity squared equals 4. Right? Now all I need to do is square root both sides, so I get x plus 4 equals plus or minus 2. And then subtract the 4, I get x equals -4 plus or minus 2. So my answer is -4 plus 2, which is -2, or -4 minus 2, which is -6, and then that gives me my answers of -2 and -6, which is what we got above when we solved this by factoring. So what's the point of this? Why on earth would I do this if I could just solve it by factoring? The reason why is because sometimes you can't solve it by factoring. Sometimes you get irrational answers. And if you get irrational answers, then completing the square will help you to get to a point where you can now square root an expression, and you can go from there. Now, in this example right here, you might ask me, well, why don't I just square root it from here? Because this stuff right here is not square rootable, and then I get into radicals in variables and radicals and all that kind of stuff. It gets extremely difficult if I were to try to solve it that way, okay? So that's why we complete the square. So let's go ahead and try question number 1. We're going to solve the following equations for x. Number 1 says to solve it in simplest radical form. So see how it says 12 equals x squared plus 6x? I'm just going to rewrite it so it says x squared plus 6x, and then I'm going to say equals 12 over here on the other side. And I'm going to leave some space for me to be able to complete the square. So if I want to complete the square, I take the b value, which is 6, divide it in half, and then square it. So I end up getting 3 squared, which is 9. So I'm going to add 9 over on the left side. Now I have two options. I can either subtract 9 to balance it out, or I could add 9 to the other side to balance it out. If it's on the same side, you have to do the inverse operation, okay? If it's on the opposite side, you do the exact same thing, because whatever you do to one side, you do to the other side of your problem, okay? So let's go ahead and factor x squared plus 6x plus 9. So when I factor this, I end up getting x plus 3 quantity squared. And the whole point of this is for me to be able to get the perfect square all together on one side and have no variables on the other side. So I get x plus 3 quantity squared is equal to 21. Now it's nice and easy. All I have to do is square root both sides. So I'm going to square root the left side and the right side. The square and the square root cancel each other out, so I end up getting x plus 3 equals, and remember, every square root has two possible answers. So I end up getting x plus 3 is equal to plus or minus radical 21. Now, in order to get the x by itself, I need to subtract 3 from both sides, and I end up getting x equals negative 3 plus or minus radical 21. So that means my two answers are negative 3 plus radical 21 and negative 3 minus radical 21. Now, why on earth did I not simplify this radical? Because 21, the only perfect square you can divide it by is 1. I can't divide it by 4. I can't divide it by 9, and I can't divide it by 16, which is too far anyways because it's not the halfway point. So this is my answer to question number 1. All right, let's do our check for our answers. So the first answer that we got was negative 3 plus radical 21. So I'm going to put in parentheses negative 3 plus the square root of 21, and then I'm going to close my parentheses, and I'm going to store this in as x. And then when I press enter, there's my x value. So then I'm going to type in the original equation. The original equation says 12 equals x squared plus 6x. And then I'm going to press enter, and it tells me it's true, so it works. Now I'm going to check my second root. So if I were to press the up button right here, and then copy it, but don't press enter. I'm just going to copy and paste it. And instead of having to retype it all in, I can just delete this plus sign and write a minus sign since it's negative 3 minus radical 21 as my second root. Press enter, and then I'm going to copy and paste my equation into my calculator. So when I press enter here, and I press enter here, it tells me it's false. So does that mean that we did something wrong? Not necessarily, especially if you end up getting this right here, this exclamation point or this caution symbol. Results obtained using approximate arithmetic. So the reason why it used approximate arithmetic is your calculator doesn't do this algebraically, it does it as an arithmetic problem. So it eventually is going to round this answer right here. So when it takes this rounded answer, it squares it, it adds 6x to it. It tells you that you'll get something close to 12, but it thinks it's not exactly equal to 12. So if that's the case, don't reject it as an incorrect answer. Test it yourself first. So we have one side is 12, and then I'm going to just type in x squared plus 6x, press enter, I get 12, even though my calculator says it's false. Right here it's telling me it's 12, and if both sides are 12 in my equation, then it worked. So I don't have to worry about it being false. All right, hopefully that made sense to you. If not, please rewind and rewatch this piece so you understand what it is that I'm saying. All right, ladies and gentlemen, so let's look at number 2. Number 2 says to solve for x again, but this time we have to round it to the nearest tenths. So the first thing you need to do is you need to have ax squared and bx together on the same side. So if the original problem says 4x squared plus 93 equals 40x, then what I'm going to do is I'm going to subtract 40x from both sides. And then I'm also going to get rid of this 93 and put it on the opposite side so that I only have ax squared plus bx together on one side. So I end up on the left side getting 4x squared minus 40x, and then these 93's cancel, and these 40x's cancel, so I end up getting equals negative 93 on the right side. Remember, we learned in the last video that it's much easier to complete the square if a equals 1. So what I'm going to do is I'm going to factor out a 4 to force my a value to equal 1. So I get 4 times x squared minus 10x, leave some space to complete the square, equals negative 93. All right, so now all I have to do is take my b value, which is negative 10, all right? So I'm going to take negative 10, I'm going to cut it in half, and I'm going to square it. So I end up getting negative 5 squared, which is 25. So I'm going to add 25 right here to complete the square. But if I add 25 over here, I need to add 4 times 25 on the other side. So I'm going to have to add 100 to the other side. So now once I do that, once I figure that piece out, all I have to do next is factor what I have right here. So I've got x squared minus 10x plus 25. It's a perfect square trinomial. It's x minus 5 quantity squared with the 4 on the outside, and that's equal to 7, because negative 93 plus 7, when you combine like terms, is 7. All right, excuse me, negative 93 plus 100 is 7. Now isolate the perfect square. So I'm going to divide everything by 4 right here. So once you divide everything by 4, you end up getting x minus 5 squared, or x minus 5 quantity squared, equals 7/4. All right? Next thing is, just like we learned before, you got to square root both sides. So you end up getting x minus 5 equals plus or minus radical 7 over 2, and I got over 2 because the square root of 4 is 2. So then you're going to add 5 to both sides, and you end up getting x equals 5 plus or minus radical 7 over 2. But the question is, what is this answer rounded to the nearest tenths? So in order to figure that out, I'm just going to type both of these into my calculator. So one of my answers is going to be 5 plus radical 7 over 2, and the other answer is going to be 5 minus radical 7 over 2. So let's figure out what 5 plus radical 7 over 2 is. So 5 plus the square root of 7, and then make sure you get out of your radical before you divide by 2, because the division by 2 is on the outside. So that's your first answer. Rounded to the nearest tenths, you end up getting 6.3. So your first answer that you have here is x is approximately equal to 6.3. And then the second answer is 5 minus radical 7 over 2. So I can just go right up here, copy it, paste it, but don't press enter. Change the plus sign into a minus sign. Now press enter, and then give your answer rounded to the nearest tenths. You end up getting 3.7. So this right here ends up being approximately 3.7. So your two answers are 6.3 and 3.7. Okay? So now let's do our check. When I do my check, I'm going to type in 6.3, and I'm going to store it in as x, okay? And then I'm going to type in my equation. So I get 4x squared plus 93 equals 40x. And when I press enter, it tells me it's false. So does that mean that I solved it incorrectly? Absolutely not. All it means is that I did some rounding. So my answer is not exactly 6.3. So what I'm going to do instead is I'm going to type in the left side of my equation, which is 4x squared plus 93, and I'm going to press enter. And I get 251.76. Then I'm going to type in the right side of my equation, and I get 40x and press enter, and I get 252. And they're very close to each other. They're not exactly the same, and they won't be the same because we rounded our answers, but they're close to each other, which means that rounded to the nearest tenth, 6.3 is most likely correct, okay? So now let's try the same thing for 3.7. Take 3.7, store it in as x, press enter, and then let's copy and paste the left side of our equation, 4x squared plus 93, The left side of my equation is 147.76, and then the right side of my equation says 40x, so press enter for that, and you get 148. Again, they're very, very close, so most likely my answer is correct, okay? And that's that. Let me know if you have any questions about anything we talked about, and have a wonderful day.